In question 10, the diagram shows the curve y equals to sin x cos square 2x and its maximum point M. In part 1, using the substitution u equals to cos x, we have to find the exact area of the shaded region bounded by the curve and the x-axis. Now, to find the area of the shaded region, we'll have to integrate the given equation, which is sin x cos squared 2x dx, and the limits are pi upon 4 and 0. Now, as we have to use a substitution, so the first step is always to first write down the substitution, which is u equals to cos x, and also write the derivative of the substitution, which will become du by dx, which will be equals to negative sin x. So when we are substituting in place of dx, so dx will be is equals to minus du upon sin x. So substituting in place of dx, so the first thing to remember when we are doing substitution is, before we do any substitution, in place of dx, first we'll make the substitution. So this will become sin x cos squared 2x, and we'll write minus du upon sin x. So sin x and sin x will cancel out. This will become pi upon 4 and 0. Now we are left with cos squared 2x, and as a substitution is u equals to cos x, we know that the identity for cos 2x is, so cos 2x is equals to 2 cos squared minus 1. And now in place of cos squared, we can put u squared. So this will become 2u squared minus 1. So this can be written as 2u squared minus 1. And as it is a whole square, so we'll put a whole square over here, minus du. And as the function is now in terms of u, so we'll have to also change the limits. Now, as u was equals to cos x, so in place of x, when we put pi upon 4, so this will become u is equals to cos of pi upon 4, which is equals to 1 upon root 2. And when we take cos of 0, which will be equals to 1, so the limits will be 1 and 1 upon root 2. Now, before integrating, we can first expand this expression. So when we expand this, this will become, so 2u square whole square, that will become 4u to the power 4 minus 4u squared minus 1. And now integrating 4u power 4, we'll get 4 upon 5u to the power 5 minus, so integrating u squared, that will become 4 upon 3u to the power 3 minus integrating 1, we get u. And now substituting the limits, which was 1 and 1 upon root 2, we can leave the negative sign outside as it is. Now substituting x equals to 1, we will get 4 upon 5 minus 4 upon 3 minus 1. And so this will be a plus 1 over here. When we whole squared, a squared minus 2ab plus b squared, so this will become a plus 1. And then we substitute the lower limit, which is 1 upon root 2. So this will become minus 4 upon 5 into u to the power 5. So this will become 1 upon root 2 to the power 5. And I have to write this so that we only have a single page for this answer. So we have to make sure that all our working fits inside this page. So this will become 4 upon 5 into 1 upon root 2 to the power 5. Then 4 upon 3 into 1 upon root 2 to the power 3 plus 1 upon root 2. So 4 upon 5 minus 4 upon 3 plus 1. When we take the LCM and simplify this, this will become, so the LCM will be 15. This will multiply by 3. This will multiply by 3. This will multiply by 5. This will multiply by 5. And this will multiply by 15. So this will multiply by 15. So we'll get 12 minus 20, which is minus 8 plus 15, which is 7 minus, so 1 upon root 2 to the power 5, that will become 1 upon 4 root 2. 1 upon root 2 whole cube, that becomes 1 upon 2 root 2, and 1 upon root 2 will remain as it is. So as we have to give the answer in an exact form as it is given in the, we have to find the exact area, which means we cannot give our answer in terms of decimal. Else we could have just substituted this in the calculator and found the exact value in terms of decimal. So now simplifying over here, now we have this 4 and 4 will cancel out. This 2 will cancel out with 4. Now, as we have a root in the denominator, we can multiply and divide by root 2 in the numerator and the denominator. So this will become root 2 upon root, and in the denominator, when we multiply by root 2, so that will become 2 times 5, which is 10, minus, so multiplying by root 2 over here, this will become 2 root 2 upon, and this will be 3 times 2. as root 2 times root 2 becomes 2. So 3 times 2 is 6 plus, and this will become root 2 upon 2. Now taking the LCM over here, we'll get 7 upon 15 minus, so the LCM of 10, 6 and 2, that is 30. So this will multiply by 3. So this will become 3 root 2 minus multiplying this by 5. This becomes 10 root 2 and multiplying this by 15, that becomes 15 root 2. So 3 minus 10 is minus 7. Minus 7 plus 15 is 8. So we'll have it, the answer will become 7 upon 15 minus 8 root 2 upon 30. And we can simplify it and write it as 7 upon 15 minus 4 root 2 upon 15. Now we can bring in the negative sign that we left out in the beginning, which was over here with the negative du, or we can leave our answer in this form, as both of the answers represent the area. So even if we leave our answer in this form, this will be the correct answer for the area of the shaded region. In part 2, we have to find the x coordinate of M, giving our answer correct to 2 decimal place. Now we know that M is the maximum point, which means first we'll have to find the dy by dx, as y was given as sine x, and it was sine x cos squared of 2x. So as they're multiplying, we'll have to use the product rule. We know that dy by dx will be is equals to v u dash plus u v dash. So taking u is equals to sine x, u dash, or the derivative of u, will become cos x, and v is cos squared 2x. So we can write it as cos 2x whole squared. So finding the derivative, 2 will multiply over here. This will become 2 into cos 2x, and the derivative of cos 2x will become minus 2 sine 2x. The derivative of cos is sine, and the derivative of 2x is 2. So this will be minus 2 up over here. So simplifying, we'll get 2 times 2, which is 4. So minus 4 cos 2x sine 2x. So once we have the value of u dash and v dash, now we can just substitute these values in the calculator. This will become, so v u dash will become, so v is cos squared 2x. So this will become cos squared of 2x multiplied by cos of x. And as it is a maximum point, so now we can put dy dx as equals to 0. Plus, and uv dash will become sin x into minus 4 cos 2x sin x. So this will be sin x into minus 4 cos 2x sin x. We can take the this term sin x into minus 4 cos 2x sin x on the left hand side. So this will become 4 sin x cos x, and this is 4 sin x, and this was a sin 2x over here. So this will be sin 2x. So 4 sin x, and this is sin 2x cos 2x, is equals to cos squared of 2x cos x. Now we can cancel out cos squared 2x with cos 2x with cos squared 2x. Now in place of sin 2x, we can substitute. So sin 2x is the same as 2 sin x cos x. And as we have to solve the equation, so we can bring our equation in terms of either sin x or either cos x. And in place of cos 2x, we can write 2 cos squared minus 1 into cos of x. So cos of x will cancel out with the cos of x on the left hand side. We'll be left with 8 sine squared of x is equals to 2 cos squared minus 1. Now, if you want to bring it in terms of cos squared, so in place of sine squared, we can write 1 minus cos squared is equals to 2 cos squared minus 1. Opening the bracket, we'll get 8 minus 8 cos squared is equals to 2 cos squared minus 1. Taking 8 cos squared on the right hand side, this will become 10 cos squared. Taking minus 1 on the left hand side, this will become 9. So cos squared of x will be is equals to 9 upon 10. So now we just have to square root 9 upon 10 and then take cos inverse. So substituting this value in the calculator, we'll get, okay, so cos inverse of square root of 9 upon 10. So that becomes, okay, so just a moment. So that will become 9 over 10. And as we have to make sure that our answer is in, as our answer is in radians, we'll make sure that calculator is in radian mode. So this will become 0.3217. So the value of x will be 0.3217. Rounding off our answer off to three significant figures, our final answer will become 0.322 for the value of x. And as we had just had to find the x coordinate of m, so we'll just leave our final answer as 0.322.